Hi guys, I'm Steve Dickman. I'm a physics teacher at Evanston High School. I'm trying to create or have created physical simulations of simple harmonic motion, a ball bouncing against the floor, a free fall with air resistance, and a lunar motion model, as well as a sine wave. That's what I've created. I thought at this session here, I would show you my simple harmonic motion, which is in 1 and 2 dimensions. And that is a turtle attached to a spring that is one end is fixed in the center of the screen. So it will just go back and forth or around. And I have it here and I will show you. We will set this up and go. And here you see, the x coordinate, x position with time, and the velocity in the x direction with time. And you see it's plus minus as it goes back and forth, plus minus, plus minus. And this is the acceleration. These are subsequent slopes of one another. Fancy word is derivative. So you can see where this slope is negative, right? This value should be negative down here, and then as well down here. Where this slope is positive, right? The velocity should be positive, okay? And I will have the kids, if I tighten up the spring, make it more responsive, what will happen? And oops, I didn't mean to do that, but there you have it. She's going back faster and faster, as you might expect. But if I increase the mass, if I give the mass more inertia, and you know what I'd like to do, actually, guys, I'd like to do that as in running. But you see that if I increase the mass, interestingly enough, the position increases. You see that? The endpoints increase. And that's because it's harder for the spring, right, to slow down the mass as it has more inertia. So again, all this will all come back to revert to Newton's laws. So there's a lot of physics. There's a lot of physics. All the physics is in every interaction, physical action. But at any rate, that's what I have for learning about basically the law of inertia, frequency, period, and the relationship between, a more complicated relationship between x, distance, time, and velocity and acceleration, which of course are all important. All right, we define our motion by, we define many things by motion. And here's my code, and I have in here velocity, so we could kick it up or down, give it a little kick, and what ensuing path will that make if I give it a velocity? It's going a little fast, guys. Sorry. But notice this does stay the same, but I get an ellipse, which is neat. As a matter of fact, that's one of the things in the Principia, the Newton wrote. He has this. I guess he did it to connect it with the planetary orbits, but that's kind of neat. But they get to see the ellipse, right? And the same thing if I make this bad boy heavier, right? What will happen? She should start to fly out more because it's harder for the spring. See that, to rein it in. Okay. So again, that interplay, right, between mass, force, and motion, i.e. dynamics.